So this is my second tutorial on cable stayed bridge for Midas Civil. In the first one I've shown how to model this cable stayed bridge, and now I will show you in this one how to make the construction stage analysis. So construction stage analysis is used to check the stability during the construction at each stage and to review the stress at each construction stage. So it is very useful to understand the stability of the bridge when it is constructed. So the method which is used is to construct first the side span girder and the towers, then the cables are put and some girders are constructed stage by stage until the final key segment installation. So this type of construction stage analysis is called forward analysis, but in this tutorial I will use another method, which is the backward analysis. So here it is. So I will first go from the last step where I have the equilibrium, and I will come back to the first step. So let's come back into Midas Civil, and the first thing I will do is to open the previous model I used in the previous tutorial. So it is here. So don't forget to save this model with another name in order to have it for final. So you can call it construction backward, for example, and save it. Okay. First of all, we'll import the initial cable tension force, but before doing that I will suppress the load combination I've used in the previous tutorial. So just select the load and delete them, and in the load, static load and static load cases I will also delete the tension loads defined previously. So delete. Okay, and I will create a new step called pretension. It is an user defined load. You can enter pretension in the description and add. Previously I used truss element to model the cables of this cable stayed bridge, but now I will change it to cable elements. So to do that I will go in the node elements, change parameter. So first select all these truss elements, add, and here in element type choose truss tension only, choose cable, and choose the pretension load you just created and click on apply, and then you will see here in the message window that the elements have been changed. Next step will be to assign again the pretension load on all the cables, so as I have done in the previous tutorial. So load, temporary pre-stress, and here you have pretension load. So the value of the loads will be the one which have been calculated in the first tutorial using the optimization technique. So here in this table you have all the values that I have to assign to my bridge. So what you can do is just use this value and assign them again to the bridge. So I will show you how to do that. If you want to download this PDF tutorial, you can go on our website midasuser.com, and you will be able to download all the tutorials, so the cable stage file for Midas Civil and the PDF tutorial. So let's go in Midas Civil, and to select the cables I will use the same technique than previously. So I will use the selection tool called intersect line, and load case choose pretension. Okay, and you have to choose the cables like that. So if you don't see well, you can make a zoom to select. And for the value, so it was 1001.63. Click on apply, and just do the same for different groups until you assign all the loads. So I will pass on this step because you already saw the process. I will assign all that. Okay, now it's done. Now I will generate the stages for the construction stage analysis. Define construction stage, generate. Here you can call it CS 0 to 32. Check the save results for each stage and click on OK. Now you have generated the 32 stage for this backward construction analysis, and you'll have to modify one by one in order to assign the good condition for the analysis. And now I will create some structure groups to which will be used for the construction stage analysis. Enter the name SG, like structure group, 0 to 32, add, and this will be created automatically. Now let's assign the elements into the different structure groups. For the first one, SG0, we will assign all the elements, so just click on select all and then drag and drop the structure group to assign every element on it. The second stage, SG1, will be the removal of the additional dead load, so we don't need to assign any element to it. And from the second group, we will assign first the element in the middle, like that. And in order to see better what is happening, we can inactivate this element afterwards. And from SG3 and SG4, we will begin to remove the cables and the girder successively. So for the first one, SG3, we will select these cables here, assign SG3, and inactivate. Now we can do the same on the other side, so be sure to select only 2 cables, not 4, like that, SG4, and inactivate. And for SG5, select the girders here and assign them. Now we just have to do that successively to all the cables and all the girders in order to create all the structural groups for the construction analysis. Okay, now that we have assigned all the structural groups, we can do the following step. Now let's create some new boundary groups. So we'll do the same for the boundary. Click on new. The first one we'll create will be called fixed support. Add. Create another one called elastic link. Oh, sorry. And the third one will be bent. And rigid link. Now close that. You can activate again all the bridge. And here you just have to drag and drop it in the window. So the first one is support, so I will inactivate all the others. Click on OK. And by doing like that, it's possible to assign the boundary condition to the groups. Rigid link. So I will activate everything except rigid link. Okay. Now we'll also assign the boundary condition for the temporary bends to a boundary group. So we will input the boundary condition as hinge condition, dx, dy, dz, and rz at the center of the side span. So click on ISO view, okay. Then go into boundary, define support. Select the nodes 86, 29, 130, and 63. Enter. So the nodes which has been selected are these 4 ones. Then go into the boundary group and select boundary group name. Yes, select bent, option add, and super type all and rz on, and apply. Now I will assign a load group. So this loading condition will become added and deleted in each construction stage to each corresponding load group. The loads considered in backward construction stage analysis are the self-weight, the superimposed dead load, and the initial cable press stress. So first we will generate that. So close this and click on load group, new. The first one will be self-weight. Then we add the additional load. And finally the pretension load. And close. Now we'll go into load, static load, and assign this self-weight to the self-weight load I just created. Just assign -1 to z direction. Click on add, and I have to delete the previous one. Okay, close. Now to define the two other load group, I will do like for the boundary condition, so I just drag and drop it here, and here I will only activate the beam loads. Okay, and for the pretension load, I will let only the pretension loads. Now I have to define the construction stage. So go into construction stage, define the construction stage. So click on CG0 and modify, and here activate the save results. So okay, it's done. Element tab have to go into group list, SG0, and activate. So here you have the table called activation and another one deactivation. So to activate SG0 you just have to add it to this group. Now you have three tabs here: element, boundary, and load. So to activate the element, it's in the element tab. Now for the boundary, have to go in boundary, and here fixed support, elastic link, and rigid link, and choose original for the support and spring position, and click on add. Now the last one, the load, choose the three types of load and activate them all. Now click on apply, and we have to do that for all the steps. So the first one, CS1. For this one, the only thing that will change is that the additional load will be deactivated, so we have to add it here. Apply. Now from the CS2 element tab, here we'll deactivate CG2, so add it in the deactivation tab. The element force redistribution is 100%. Boundary tab will activate the bend, because during the construction stage these bends will be here in order to help to have some not too much stress inside the bridge. And now from CS3 to CR32 we have to unactivate the corresponding element, so just add it to the activation window, so CS4, and just have to do that for all the stage. And the last one. Okay. Now let's go in the construction stage analysis control. Here we have to activate last stage here, and to unactivate include time dependent effect. So this is if we want to use a creep or shrinkage. Here we will not use that. Let's just click on OK. Okay, now the analysis is done. So let's review first the results. Let's look at the deformed shape. So you can choose a load combination, and let's view the result for the first stage, CS0, and choose the load case summation, dxyz. For the deformed shape, enter of scale factor of 0.5, check the undeformed value, and apply. So now you see the deformed shape for the first stage, and if you click here, you can view the construction stage by stage of the bridge. So you see, remove the cables and the deformation for each stage of the analysis.